Objective number 3. Use summation notation. Example 7. Expand each sum. We notice that this is a sequence, and the sequence with the variable k. We normally use n, but we can use the other letter. For example, we can use a k. And the k begin from 1 and is n at n for some n number integer. So k from 1 to some integer n. So what do we need to do is, first of all, we will plug k equal to 1, and then k equal to 2, then k equal to 3, then k equal to 4, and so on. For example, n is 10, then you will plug into 1 over 10. And in this case, n represents for some number. So after we plug them in, the notation sigma means we add them. So we add 1 over 1 plus 1 over 2 plus 1 over 3 and so on. In problem B, we will plug in k equal to 1, we will get 1 factorial. We plug in k equal to 2, we get 2 factorial. 3, we get 3 factorial, and so on, until we plug in some number n, so n factorial. Then we will add them up. And we recall from algebra, the factorial means, for example, if I have 5 factorial, I will do 5 multiply 4, multiply 3, multiply 2, multiply 1. If I have 3 factorial, I will begin from 3, multiply 2, multiply 1. 1 factorial is 1, and also 0 factorial is 1. You can use calculator to find the 5 factorial. And what we need to do is, if you do manually, you just need to multiply them out. So we will get the answer for 5 factorial is 120. Example number 8, that is the opposite of example number 7. So we have the expand form. Now we need to write in the summation notation. So you can use k represent for this. So k will start from 1. You notice that you have the number, and in a number you have two numbers, base and the exponent. So you see the exponent 2 is keep the same, and the base is changing. So the base will be the variable k and k squared. So the number is a constant. The exponent 2 is a constant. So we keep it like that. And then we have from k plug in 1 until you see right here is a 9. So the k will be begin from 1 and end at 9. For problem B, we have the summation notation. The first one we can write 1 over 1 so that we can have a fraction. So on the top we just have 1, 1, 1, 1, so that will be the constant. In the bottom you notice that you have 2 to the 1 for 2, 2 to the 0 for 1, 2 square for 4, 2 to the third power for 8, and so on. So they already give you the form, which is if we have 2 to the n, but because we begin from 2 to the power 0, so we need to do 1 unit less. So we have 2 to the n minus 1. So that is already give us the form of the sequence. So 2 to the n minus 1. And we will use k instead. So k to the minus 1. And k start from 1 until n.